Okay, now we're going to talk about rational equations. These are ones where the variable is in the denominator, at least for some of the terms. So one of the first things you have to do is make sure all the denominators are the same, or I like to say alike. So notice we have an x squared, we have an x squared, and in order to get this to be x squared, we would have to multiply. If you multiply this denominator by x, then you have to multiply this denominator x. Now, all of the denominators are the same because x times x is x squared. So now, once denominators are the same, you can ignore. It doesn't go away. You can ignore the denominators and just solve the numerators. Solve the numerator section. Numerator. Right? So we have 6 is equal to 1 plus 1x is x. So now we're just going to subtract 1. So 5 is equal to x. Now, there is one caveat to that. If you have y is equal to 1 over x, if you type almost any number into the calculator, 1 divided, you've just got a fraction. 1 over 2, 1 over 8, negative 1 over a million. It all works, except for whatever caused the denominator to be 0 in this case. If it's just x, where x is equal to 0 causes the denominator. And when you get that, you're going to type 1 divided by 0. You're going to get a domain error. And that's because when you type in the x value of 0, what happens is you end up with an asymptote. So when you're solving rational equations, you have to state which values don't work. So this would be your answer right here. So you'd say x is equal to 5, put a comma. You'd also have to state where x cannot equal 0. So that's what you'll be doing for these. So on this one, the largest denominator is 5x squared. So we would have to multiply this denominator by 5. So this numerator times 5. This denominator we would have to multiply by not only 5, but also by x. So up here we'd have to multiply by 5x. Now all the denominators are the same. They're all going to end up saying 5x squared. We can ignore them. So 5x times 1 is 5x. 5 times 1 is 5 is equal to 1. So we're going to subtract 5. So 5x is equal to negative 4. Divide the 5, the attached 5. Now that's what x does equal for this equation, but notice if you've got 1 over 5x squared, the only number that will force this to be 0 is 0. So you would say where x cannot equal 0. Let's do one a little bit more complex. Now we've got an expression. When you have an expression in the denominator, there's almost always going to be 2 places that x can't equal. So first thing we're going to do here is we're going to, again, find like denominators. And we might have to start by factoring the denominator. So these have an x in common. I'm going to leave the numerator, just to save time, I'm not going to rewrite the numerator. So I'm going to factor out an x. Remember, that's like it's the reverse distributive. So x squared, when you factor out an x or divide an x, leaves x. 3x, divide x, leaves a 3. So that's that denominator. Well, this denominator is the same. So we'll put x plus 3. Ooh, that's a subtract. So we're going to subtract whatever's up there. And this one just says x. So if we look at the denominator, Ah, the only part that's missing is this x. So we're going to multiply, well, what was up here was a 1. All right, so now all the denominators are the same. Now I'll put the numerator. So I've got x subtract 6 is equal to 1 subtract 1 times x is x. So let's see, that's a subtract x. I'm going to add x to both sides. That will give me 2x. Then I'll add 6 to both sides. Divide both sides by 2. So x is equal to 7 halves, where, now let's look at the denominator. Remember what I've said before, anytime you have an x on the outside of parentheses, that x will always equal 0. So you could have negative 5x to the 4th. This thing right here, what forces this, here's another way to think about it. Set both things, set the outside thing equal to 0. So in this case, oh look at x is equal to 0. And then set this equal to 0. Well, we've already, that's supposed to be a plus sign right there. So the opposite of 3, x will equal negative 3. So where x cannot equal negative 3 or 0. That's how you do ones where there's factoring. So, this one became more complex. So notice, let me give you an example. What if we had 1 over 5 subtract 1 equals 7 over 5? Well, I could just turn 1 into 5 over 5. So this really should have been 12 right there. Right? 1 is the same as the numerator and the denominator being the same. So what we're going to do here, this one we're going to rewrite as 1 over 1. And then look at, on both of those, we're going to multiply by 8x subtract 5. Now all the denominators are the same. So 1 minus, we're subtracting all of this. 1 times 8x is 8x. 1 times negative 5 is negative 5. Now this subtract goes to both of this. So this says 1 subtract 8x, but this says subtract a negative. Subtract a negative is the same as adding 5. And then look at, these two things can be added together. So now we have negative 8x plus 6 is equal to 7. I'm going to subtract 6 on both sides. Negative 8x is equal to 1. Then when we divide both sides by negative 8, x is equal to negative 1 over 8. And then you say, where? So we take this denominator, 8x subtract 5. Either set it equal to 0. If that's easier for you, to set it equal to 0 and add 5, 8x equals 5, then divide 8. That's fine, you can do it that way. Or you can say, let's just do the opposite of each operation. So the opposite of negative 5 is positive 5. The inverse of multiplying 8 is dividing 8. So where x cannot equal 5/8. It does equal negative 1/8, but even if there were other things going on, if 8x subtract 5 is the denominator, 5/8 is the only place where x can't be. All right, that's it for this one.